Okay, cool. Let's get started. I think 2 people are missing, but we can make it without them, I think. Okay, so I'm gonna share a link to a test. Okay, one thing to tell you guys before, it's not really something that warrants specific coverage because it's very easy to understand and you guys should be familiar with the concept from maths. C#,
textbook, it says Microsoft on it. It has like a bounded thing at the back.
Background noise. Okay, hold on, let me just mute all. There we go. Okay, so I'll share the link to the test now. Just know C# does know and follow BODMAS. Okay, so you know what BODMAS is? When you tell C# to do maths, it follows BODMAS. That's all I'll say. Okay, anyway, so the link to the test is in the chat. You can follow that link, just fill in, all your details. It's pretty self-explanatory, I think. And yeah, fill in the test. There's 17 questions. I think you should find pretty much all of them quite familiar and all quite easy, except maybe question 16. Question 16 could be a little bit tough. If you guys have any questions regarding, not directly regarding the answers to the questions, obviously, then you're welcome to post them in the chat. I'll give you guys about 45 minutes, so we'll stop at 3:15. Okay. If some of you guys, that's sort of plenty of time, but if some of you guys can't finish because of question 16, then we'll extend the time a little bit. Like you can write through the break, for example. Then we'll start again at 3, at 3:30 after you guys finish the test, and I'll go through it with you. Okay. So yeah, just write the test. Shouldn't be too difficult for you, but it should give us a better idea of what it is you guys are struggling with. And after you finish that, we'll go through the test together, and any questions you guys have about chapter 1 in general or the test specifically, that would be a good time to ask them. Okay. So yeah, good luck guys, and I'll watch the chat for any questions.
Sir, like my Wi-Fi was like being stupid. Like, sir, what did I miss?
Okay. Do you see the link in the chat?
How do I access chat?
There's a little speech bubble at the bottom.
I can't see.
You're on your you're on your phone. I mean, I assume that people on their phone, because there are other people on their phones as well.
Sir, can you please send it on WhatsApp?
Yeah. Okay. Cool. It's on WhatsApp.
Okay, yes, I got it.
Yeah, just go to the link and fill that in.
Okay, thank you. Ooh, okay, I see we have 21 participants now. I'll share the link again. Sorry, you guys were late. You can have some extra time though. You'll write while everyone else is on a break. In the chat I posted a link to a Google Forms. It's also on the WhatsApp now. Just go to that link and fill in what you find there. And
it's pretty self-explanatory. It's just a test with 17 questions. You'll get a mark as soon as you submit at the end. And it doesn't count for marks, it's just to gauge where you are exactly and what it is the class is struggling with. And if you have any questions not directly related to the answers, then just post them in the chat and I'll answer them for you.
Hey, sir, I did pretty bad.
Unlucky. What did you get, if you're comfortable sharing? But if you don't want to, that's fine too. Did you pass? Ooh, unlucky. Sorry, my microphone was muted because I had some background noise earlier. Yeah, don't worry too much about it. Did you pass, if you're comfortable saying?
No, I didn't, sir.
Ooh, unlucky. Don't worry, we'll go through the test now and we'll see. And you can ask whatever you're struggling with. Well, for the purpose of this test, we'll say 50%, but for your final test, 70.
Hey, sir, how many minutes do we have left?
I think we were going for like 10 minutes. Oh yeah, Ethan, you did finish quite early, eh? Yeah, it's 12 minutes left. Say, for those of you who arrived late, you can take some extra time if you're worried. But what's the thing? If you're finished, can you post done in the chat?
Yeah, I just don't understand the for, while, and do while, etc.
Okay, we can go over that a bit now when we go through each question. Cool. Cool. You guys are welcome to go get something to drink, because obviously I won't stop before 3:15. But if most people are done by 3:15, then we can just continue. Although we'll probably have a short break anyway, so people can go to the bathroom and get a drink after they finish the test. Cool. So that's about 1/3 of people done, right? 7 out of 21. That's good timing.
Just wait for the others still. But yeah, then for those of you who are done, you can consider yourself on break until about 3:15, and then we'll see where we go from there. 2 more minutes, guys. Okay. Cool. So if you're not done yet, maybe just guess C, move on, and we'll go through it now. But note down whatever you're struggling with, and we can go through it later. So I think maybe since some people will just be finishing the test now, maybe take a little bit of a break, regain your composure. If you haven't finished, I guess you can write through the break as well, and then we'll reconvene and go through the test together. Okay, and we'll just go through every single question. If you were struggling with any questions in particular, then do say that you were struggling in the chat, so that I know to stop and pay more attention to that question. Okay. But yeah, so let's kick off again at 25 minutes past 3. Alright. And I know, so we did start at 2:30, so some people were wondering whether or not we would go until 4 or 4:30. I will be lecturing until 4:30 because I have to do 2 hours. And I imagine there'll be enough questions. If Bryanston was anything to go by, there'll be enough questions to last until about 4:30. So if you can't stay for the full thing, because we did change the time, then please just catch up the last 30 minutes in the YouTube video, which I'll post afterwards, okay? So yeah, take a little break, go get some water or something, and come back at 25 minutes past 3, alright? And think about what you want to ask. Okay, let's get cracking again. I'm gonna share my screen quickly. Okay, that's done. It's actually easier if I open up the app on my phone as well, so that I can see your chat while I see the screen. Let me just do that. But in the meantime, what was your general feeling, guys, about the test? Similar to what we did last week, right? Why is it doing this? Let me mute. Shit. Oh no, 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 no. Oh, I'm so dumb. Ugh. Sorry about that, guys, that was silly of me. My phone was just causing like this weird static issue, and for some reason I clicked the button. For some reason the button to hang up on my phone is right next to a button to end the meeting, which I do think is a bit silly, but it also is my fault for not reading the button. Okay, let me see if this time the meeting... Okay, start it again. Now please do not cause that horrible sound. Okay. Okay.
You need to mute the mic on your phone or on your laptop.
I did mute it on my phone, but it doesn't. Okay. There we go. Let me see if the phone audio works better. Okay. So now the audio is on my phone. That does seem to work better. Okay, are we good now? So you guys can still hear me, right? Good stuff. Okay. Cool. Okay, so now I can see the chat and see my screen simultaneously. Let me share my screen. Alright. Cool, so let's go through this test. But yeah, in the meantime, what was your general feeling about... Mute this. What was your general feeling about the test? Bad, good, average? Wasn't bad. Okay, that's good. Okay, let me open the test here. Okay, yeah, so the first few questions should have seemed pretty familiar to you guys, alright? Let me just make sure, has everyone rejoined? Seems like we're still missing a few people. Yeah. I would have expected question 15 to be quite difficult for some people. I mean 16, sorry. Question 16 to be quite difficult for some people. But I think when we get to it now, you'll see sort of why it is reasonable to ask. Also made some dumb mistakes. Okay. I mean, that's always going to happen in tests, right? But also, I mean, one maybe benefit you can see of doing this again and again is that there's only so many multiple choice questions they can ask on these topics, and so by the time you get to the test, a lot of them will look very familiar to you, so you'll be less likely to get nervous and make some of those mistakes. Sorry, I was just making small talk while some people joined. Okay, so it looks like 3 more. Okay, this is fine. Alright, yeah, let's get started on this. Okay, so question 1, I think let's do this cooperatively, so do post in the chat what you think the answer is, so that I can also gauge how much time we should spend on each problem. Alright, so you need to gain a better understanding of the solution before writing the program. You decide to develop an algorithm that lists all necessary steps to perform an operation in the correct order. Any technique that you use should minimize complexity and ambiguity. Which of the following techniques should you use? A. Flowchart, B. Decision table, C. C# program, or D. A paragraph in English. Okay, so someone says flowchart. I think that's a pretty good answer. Alright, this one shouldn't have been tough, right guys? Yeah, so flowchart is the correct answer. So the only 2 you really should have been even giving attention to are flowchart and decision table, and because they say an algorithm that lists all necessary steps, obviously a decision table doesn't show all the steps, right? It is a simple way of visualizing the sort of decisions that your algorithm will make, but it doesn't show all the steps. Flowcharts show all the steps. Okay. Cool. That one shouldn't have been difficult. If any of the questions are the ones you struggled on specifically, then do mention it. Okay, so that we can stop. Which of the following languages is not considered a high-level programming language? 2 answers already. That's good. That's good. Okay, so 2 people say common intermediate language, and yeah, that's correct. Okay. That one also not too tricky. It mainly comes down to whether or not you remember, right, some of the discussions we had earlier on in the course. Okay. You are writing code for a business application by using C#. Weird English. You write the following statement to declare an array. Int square brackets, so it's an array of ints. It's called numbers, and it's holding 1, 2, 3, 4, and 5. Now you need to access the second item in this array, the number 2. Which of the following expressions should you use? Numbers 0, numbers 1, numbers 2, numbers 3. Okay, cool. Lots of people already answering 1, 1, 1, and yeah, you guys are correct. So what was this testing? All this was testing is, do you remember what we could call maybe the golden rule of arrays? We start counting at 0, right? So position 0 would be 1 here, position 1 would be 2, position 2 would be 3, and it looks like they chose this list particularly to trick you, right? But you guys seem to have gotten that one pretty good. So yeah, numbers 1 is the correct answer. Okay. This one may be a bit tricky if you weren't paying attention last week. You are developing a C# program. You write the following code: int x equals 10, int y equals plus x, int z equals y plus plus. What will be the value of the variable c after all the above statements are executed? Okay, 10, 11, 12, or 13. Oh, okay, it looks like at least a few people were concentrating last week, so that's a good start. Does anyone want to go over the little trick that makes this answer 11? Yes, please, yes, please. Okay, let's do it then. Okay, so I'm just going to do it in .NET Fiddle. You can do it wherever you want. But let's... okay, so we could say I'll do the example exactly here first, okay, and then we'll explain it in some different ways as well, just in case this one doesn't gel. Okay, so they say int x equals 10, okay, that line, hopefully no one needs explained. Okay, int y equals, okay, plus x. I think they do that one first, right? Plus x they do first, and then they do y plus plus. Int z equals y plus plus. Okay. Console.writeLine z, so that we can get the value of z out, right? Okay, so for those of you in the chat who said 11, that is correct, but let's go into why that is correct. Okay. The way I like remembering this is a trick in how to read it, okay, but you can remember it in a rule-based way as well. Okay, so basically this little operator plus, okay, we know what it does, right? It adds 1 to whatever variable it's next to. Okay, but there's a trick in terms of this operator of it can either be the prefix or the suffix. Okay, I'm going to explain it in a slightly different way that I did last week, just in case that one didn't work for some people. Okay, if it's the prefix, so if it comes before the variable, as in the second line there, then the 1 is added before the variable is returned. Okay. If the plus is the suffix, so if it comes after the variable, then the value of the variable is returned before the 1 is added. Okay. So there's a way that I like looking at this. So I'm going to, we've seen their example in the book. Now just looking at how these different things work. So if I say console.writeLine, alright, so if I just print out x, obviously it prints out 10. Okay, so that's the initial value of x that we specified there. Okay, if I specify x plus plus, okay, so if I print x plus plus, okay, then it still prints out 10. Okay, it still prints out 10. So you might be tricked into thinking then, okay, this isn't doing anything to x. But this line here, this x plus plus, still adds 1 to x. Okay, so we can see that by on the next line, okay, I'm going to print out x. Okay, so we create a variable, its value is 10. We print it out, but we print out x plus plus. Okay, this still will print out 10. Okay, but this plus plus still adds 1 to the variable, and to see that it still added 1 to the variable, we're going to print out just the variable on the next line. Okay, so you see it goes 10, 11. Alright, so this just returned the value of x and then added 1. Okay, and we saw that it added 1 because on the next line x's value is 11. Alright. So, and we can see this done the other way. Okay, if we put the plus plus first, then 1 is added before x is returned. So now we'll print out 11, 11. Okay. So we've covered this in terms of printing, but this applies wherever you use plus plus x. Right. So in the case of the example in the book, they say int y equals, they say plus plus x, okay, and then they say int z equals y plus plus, okay. So here what's happening is we add 1 to x and then we return its value, so we get 11. But when we assign, so y's value is 11, okay, because we've added 1 to x and then we returned it. Okay. And here with z, okay, we returned y's value, which was 11, and then we added 1 to y. Okay, but z became 11. Okay, we were just adding 1 to y, not to z. Okay, and it returned y's value first. So I mean, you can see at the end of this, they were asking you about z's value, right? Z is 11. But you can see that y's value is actually 12. Okay. This line did add 1 to y. Okay. It's just that y's value returned before the 1 was added. Okay, is that a sufficient explanation of this for all of you? Do you get this? So it just has to do with whether or not the plus plus is the prefix or the suffix. Okay. If it's the prefix, then it happens before it's returned. If it's the suffix, then it happens after it's returned. Okay. Hopefully that's okay for everyone. Alright. But nonetheless, it seems like most people got this right. It is 11. So yeah, hopefully you guys are okay with that trick. Okay. You are writing a method named printReport that doesn't return a value. Let me just make sure, is this chat still updating properly? Yes, it is. Okay. You are writing a method named printReport that doesn't return a value to the calling code. Which keyword should you use in your method declaration to indicate this fact? Okay. So this we covered, was it last week or the week before last week? I forget. We discussed it quite briefly. So is the answer A, void, B, private, C, int, or D, string? Okay, cool. Awesome, yeah, good start. Everyone's saying void. Yeah, that's good. So a very simple example of what they're asking here. Okay, so the main method, alright, you can see in the main method we never use the word return, right? We never use this word in the main method. Notice that you can do this, actually. This is allowed. This is allowed. You see, because this returns nothing. Okay, so if you understand the word return, usually we say return and then some value or variable to return. Okay, but in the case where methods don't return anything, so the example that they're using here is a method that just prints something. We've seen a method that does this as well. If you guys recall the description method, when we created a method to describe the person, okay, and it just printed out a sentence about the person, that method didn't need to return anything, right? It just printed out something, okay? And when a method doesn't return any value, when it doesn't return anything, you just need to specify with the word void, okay, instead of putting a type there. Occasionally you would put a type there like int or string, but if you don't want to return anything, then you would put void. Okay, but in general, again, seems like you guys are pretty confident with that idea, so that's nice. You need to provide complex multi-way branching in your C# program. You need to make sure that your code is easy to read and understand. Which of the following C# statements should you use? Okay, this one is trickily worded, but let's see. Okay, someone says switch, switch, switch. Again, everyone's pretty confident. That's something to be glad about, I suppose. So they're a bit tricky with the wording, right? So multi-way branching, you can, and also sort of easy to read and understand. This should immediately start suggesting switch to you, right? But you see they also give these answers case, okay? And if you remember, in the switch statements we provide a list of cases, right? So we say switch, some variable, and then we provide a list of cases to compare that variable to. So you can see they're trying to be tricky by putting the word switch and the word case. Okay, but you're correct in saying switch. Switch is the right answer. And they're also in a way being tricky because we also use the word break inside switch statements, if you remember. So they are trying to trick you, but yes, the answer is switch. Okay, and hopefully we've gone through. Ooh, can't hear me properly. Should I try switching back again? So now do this, because this did work once upon a time when I switch speaker / mic. Okay. Unfortunately it doesn't let me mute the call entirely on my phone. I don't know why. Turn off speaker. Okay. Okay, this should work, hopefully. Ooh. Not totally sure. Is that better, guys? Hopefully that improves things a bit. Okay, so let's get started again. You are writing a C# program that iterates through a collection such as arrays and lists. You need to make sure that you process each item in the collection once. You also need to ensure that your code is easy to read and debug. Which of the following C# statements provide the best solution for this requirement? Okay. Someone says for each. Seems a pretty good answer to me. Any other suggestions? Okay, for each is the correct answer, guys. So what should have given this one away to you instantly? When we say iterate through a collection, that should instantly tell you that we're talking about a for each. Okay. So someone was saying that they are struggling with these different repetition structures. What's the general consensus? Do you guys want to go through a basic overview of each repetition structure again, or are you okay with this? Yes, please. Okay. No. Okay, well, let's do it quick. It's a bit, I can't really hear you guys now, unfortunately. How do I fix this? It's a bit annoying. Is that? No, that's too loud because that'll cause echo. Okay, let's just do it. Okay, so someone wants to go through it, so we'll go over just quickly all the different loops again. Okay, so a while loop, if by this point hopefully you get this one. Okay, so this is probably the most basic repetition structure. Okay, so you just give it a condition. It works very similarly to an if statement. Okay, so you specify some kind of condition here. We have our loop initialization here. Okay, and we can put any code inside the loop, as is quite typical. Okay, and our loop increment also occurs inside the loop. So this kind of loop is maybe it's a bit unneat compared to what you would be used to in like a for loop kind of structure. Okay, So let's see. So I don't know how I can explain this differently to how we did it. Is everyone's comfortable with this structure by now though, right? So we just have this statement here, and that'll just evaluate to true if the statement is true. So if I is less than 5, this will evaluate to true. And just like an if statement, if that statement is true, then the code in here will be executed. Alright? In all other cases it will not be executed. Okay? The only difference that the word while makes here is when we get to the end, we go back to the beginning and check again. Okay? Whereas an if statement would only do that check once. Okay? So that's the most basic loop structure. We also have a do-while loop, which is also tested later in this test. So if people are having problems with that, we'll cover it then. But the only difference between the while loop and the do-while loop is that the do-while loop does not check the condition the first time it is run. Okay, so what do we mean by that? Maybe one easy way to see it is that you literally read the code left to right. That is what the computer will do. So it gets to the word do, okay, and so without question, it doesn't check anything, it just does this. Okay, it just executes the code. It goes, okay, I'm going to print out I, and I'm going to add 1 to I. Okay, it then gets to the while loop and the condition, and then starts checking the condition and just enters a normal while loop structure. Okay, so the only difference between the while loop and the do while loop is that the do while loop checks at the bottom, okay, whereas all other loops basically check at the top. Alright, so not too much to do there. Okay, the for loop, how I explained it to you, is more just that it's more convenient structurally. Okay, it's easier to read. So how we can see that, let me go back to the while loop. Okay, so we have this while loop. Okay. The initialization, where the loop starts, the loop condition, I less than 5, where the loop stops, and I++, how we get from the start to the end, so in this case going up in steps of 1. Okay, these 3 different components, you can see in the while loop, they're sort of all over the place, right? Our initialization is way up here, our condition is over there, and I++ is over here. Okay, all the for loop does is provide a neater structure, okay, a neater template for this structure, rather, you could say. Okay, so in the for loop we have our initial points, okay, where the loop starts, okay, our condition, so where the loop stops, and our increments all here. Okay, and then we can put, as usual, our code goes here. Okay, so we would say int I equals 0, I less than 5, I++. Okay, so these 2 loops were identical. Okay. So that's a for loop, alright, and so I would recommend, if by now you're struggling with this one in particular, I would suggest maybe going through one of the older lectures, because now we do have all of these lecture videos, right? And we cover a lot of different examples of what for loops can do in those videos. Okay. For this question more specifically, since this question was asking about a for each loop, okay, we had this 4th repetition structure, and there was nothing particularly special about this repetition structure. Okay, so let me make, how should we explain this one? I think one nice way of explaining this one is to actually demonstrate what you would do if it didn't exist. Okay, so we have a for loop here, and you can see it counts 0, 1, 2. Okay, as we saw in one of the previous questions, if we have an array, so I'll create an array called pretty much the exact one that they have in the book, in the test, we'll say 1, 2, 3. Okay, so we've just got a list of numbers 1, 2, 3, and let's say we wanted to print them out. Okay, as we saw, if we want to access numbers in the second element, so 2, okay, then we would access numbers in position 1. Okay, 1 would be numbers in position 0, and 3 would be numbers in position 2. Alright, luckily we have this for loop that counts 0, 1, 2. Okay, so I can say instead numbers in position I, okay, and we can see that I counts 0, 1, 2, and so this now just prints 1, 2, 3. Okay, and whatever numbers I gave it, if I said 100, 200, 300, it'll print out those 3 numbers. Okay, and we can extend this loop in size. Okay, now generally people don't like using the structure to iterate over collections or arrays like this. Why? Because you have to specify the size here, right? You have to specify the size of your array manually. You have to think about the fact that it starts at 0. Okay, you have to know exactly how large of steps you want to take through your array. This is a bit of a mission, and so instead they have created a structure called the for each loop, okay, which creates a much more convenient way to perform this exact operation. Okay, so instead of doing it this way, you create a new variable of the same type as the variables in your list that will just hold each position in your list. Okay, so for example, we would say in this case int number, okay, or int num in numbers. Okay, and you can read this as it's read in English. Okay, for each int num in numbers, okay, and in the loop you can work with this variable num and basically work with it as if it's one variable. Okay, because every single position in your list, 100, 200, 300, they will all be held in num at some point. Okay, so you'll see both of these for loops do the exact same thing. Okay, they just print out 100, 200, 300. It's just this is a more convenient way of displaying it. Okay, so that's a basic revision of all of the different repetition structures. If you're still struggling with it, maybe after I post this video, or go back to one of the earlier videos. We did that whole revision lecture, if you recall. So cool. Yeah, I can't hear very well, but I don't know. Did I hear you understand it clearly now? Hopefully. Okay. Cool. Okay. Awesome. If I heard properly. Okay, so you are writing a C# program that iterates through a collection. Awesome. The answer here is for each. Next question. You are developing a C# program that needs to perform 5 iterations. Okay, so this one, I didn't create this test, but I do not like the code formatting that they used in it. So maybe I should have recommended that you copy the code down somewhere else, because it is a bit of a mission to read this. But the question itself isn't too difficult, okay, because you can sort of deductively go through each one and see which one helps. So I think let's approach this question in that way. Okay, so you are developing a C# program that needs to perform 5 iterations. You write the following code. Line 1, int count equals 0. Okay, so that we're all okay with. Line 2, while count is less than or equal to 5. Hopefully we're all good with that too. Okay, line 3 is just a curly bracket. Line 4, console.writeLine, we just print out count. Okay, they're doing a slightly more fancy print statement, but they're just printing out counts. And then they say count plus plus, and line 6 just closes off our while loop. Okay, so I'm just going to copy this exact code into .NET Fiddle so that we can see it more clearly. Okay, so they create a variable count. It's initialized at 0. Okay, while count is less than or equal to 5. Okay, they have curly brackets. I guess theirs is on the next line. Okay, they then do their fancy print statements. We're just going to print out counts because that's much simpler, and then we say count plus plus. Okay, so that's the question that they gave you. And if we run this, we can see they didn't lie. You can see it does run 6 times. Okay, and they're asking, we only wanted this to run 5 times. Which line of code do I need to change in order to make it run 5 times? Okay, and they give us a few different propositions. Does anyone have any answers so far in the chat? Which ones did you pick in your test? Do you remember? Okay, cool. Okay, that's a good start. Awesome. Alright, so they give 4 different suggestions. For no apparent reason, I'm going to save the first one for last. Okay, so we'll go through these other ones and why they don't work. Okay, so option B, they said, change the code in line 2 to while counts equals 5. Okay, so they said, take this line and change this to while counts equals 5. Okay, so what is this doing now? This obviously won't work. Okay, why won't it work? Well, this is running while the variable counts is equal to 5. Okay, you can see initially we make count 0. So when we run this, nothing will happen. Okay, nothing happens when we run this. You could see if we made count equal to 5, then it would run exactly once. Right, because it gets to the while loop and it goes, okay, count is equal to 5, it runs, it adds 1 to count, and then count is 6, so when it checks again, it stops. Okay, so obviously this suggestion is not the answer. Alright, so that rules out option B. Change the code in line 2 to while counts is greater than or equal to 5. Alright, let's try that. So we change the code in line 2 to greater than or equal to 5. Okay, you can immediately see this is not what we want to be doing, right? Because if we're counting up, let's say hypothetically we started at 5, then this would have run for all of eternity, right, if we were above 5. Because we're below 5, okay, so we get to this line and it goes while counts, which is currently 0, is greater than or equal to 5. Okay, that's immediately false. 0 is not greater than or equal to 5. So this code never executes. Okay, so when we run this, you can see nothing happens again. So this suggestion is not correct. Okay. And then they say change the code in line 5 to plus count. So the last thing they suggest, okay, we would leave this as less than or equal to, and we would change this to plus count. Now, hopefully you guys can see, because you're not doing anything with counts immediately, this is just identical. Okay, this is identical to what we were doing before. Okay, because plus count is, in this case, in this context, the same as count plus. The only difference is plus count will return count after it's added 1, and count plus will return count before it's added 1. But in this case, it makes no difference. Okay, so all of their suggestions, except the first one, which just involves changing where this loop starts to 1, which is a pretty sensible solution, and then it runs 5 times. Okay, what was one other option? Hopefully you guys saw. Alternatively, we could remove the less than or equal to, right, and just make it less than. Then it also just runs 5 times. Okay, 0, 1, 2, 3, 4, it still runs 5 times. So there were 2 possible answers that they could request from you there. But yeah, in this case, it looks like you guys got it right, so yeah, ends counts equals 1. Okay, question 9. This is why I gave you the little hint at the beginning. You are developing a C# program. You write the following code line. Int x equals 6 plus 4 times 4 divided by 2 minus 1. What will be the value of the variable x after this statement is executed? A 19, B 13, C 20, or D 14? Any suggestions on that one? Okay, so hopefully you can see all this is testing is whether or not you know that C# does BODMAS. Okay, and it does do BODMAS. Let's see, I think I'm getting... Where are those coming from? Oh, okay, people are just saying 13, 13. Okay, cool. Yeah, that's correct. I don't think we need to go over this too much. It's basically testing whether or not you know C# does BODMAS and whether or not you know BODMAS. Okay, so 4 times 4 is 16, divided by 2 is 8. Then we add the 6, and we get 14, and then we subtract 1, and we get 13. Okay, so it is B. Alright, so yeah. Okay, next question. This one should have been easy, hopefully. We have covered data types a lot. You are writing a C# program that needs to manipulate very large integers that may exceed 12 digits. The values can be positive or negative. Which data type should you use to store a variable like this? Fantastic. Did everyone get long? We don't have to go over data types again, right? Everyone knew that it was long. Long just holds long numbers, right? Not too bad to remember. Okay, I'm going to take that as a no. We do not have to revise that again. Okay, this we covered. This next question. Actually, this question is basically identical to the exact question we got last week in the assessment in the book. You have written a C# method that opens a database connection by using the SQL connect object. The method retrieves some information from the database and then closes the connection. So basically you can ignore all that information. They're just trying to red herring you. You need to make sure that your code fails gracefully when there is a database error. To handle this situation, you wrap the database code in a try, catch, finally block. You use 2 catch blocks. Again, all of this is just trying to red herring you. You use 2 catch blocks, one to catch the exceptions of type SQL exception, and the second to catch the exception of type exception. Which of the following places should be the best choice for closing the SQL connect object? So what do we think about this? Okay, so when you see questions like this, all you have to remember is the try, catch, finally structure. Okay, what goes where? Okay, and how can we explain this nicely? The last one you think. Okay, the last one you think. Okay, you think correct. That is the correct answer. Okay, but let's maybe go through this again. Okay, so hopefully from last week, guys, I'm going to assume in my little explanation of this that you remember what objects are. If you don't remember what objects are, then go back over that lecture again, please. Although I suppose we will cover it again in more detail later, but not right now because we'll run out of time, and I do at least want to finish going through the test. Okay, so this was the try, catch, finally structure. Okay. Regardless of what it represents to you right now, kind of how we begun understanding the concept of a class and a namespace before, I just want you to associate the general purpose of each section. Okay, so try just contains something that we're worried about failing. Okay, so for example, opening up a connection to a database. A lot could go wrong in that process, right? The internet might not be connected. Something might be unplugged. The database might not exist. The URL might be wrong. You know, there's infinitely many things that could go wrong. The SQL query that we're performing, or the thing we're asking the database for, could not exist. Don't worry about what SQL query means. We cover it in the last section of the course. So there's a whole lot of things that could go wrong when we open a database connection. Okay, and so that and other things like even division, there are a bunch of high-risk operations that we might be worried about failing. And those kinds of things we put in a try. Okay, so if you're worried about code causing an error, you put it inside a try block. Okay, inside the try block. Okay. Now the catch statement is used for catching specific types of errors. Okay, so you can see, again, this was a red herring in this question. Okay, but they say, in this case you used 2 catch blocks. Okay, so the one catch block was catching things of type SQL exception. Now you don't need to know what that means. Okay, all you can see is that is a type. Okay, it's SQL and then the word exception. Okay, so I can put anything before the word exception, divide by 0 exception, stack overflow exception, out of memory exception, any exception. Okay, anything followed by the word exception, you just need to know, okay, that's a type of thing that could go wrong. Okay, it's a type of error. Okay, if there is nothing before the exception, like here, so there it's just the word exception, then it means any error. Okay, any error. So that's not too difficult to understand, right? This, if there's something before the word exception, it's looking for a particular kind of error. If there's nothing before it, it's just any error. Okay, so this had 2 catch blocks, one looking for any error and one looking for a particular kind of error. And that's all the catch block could ever do. It's either looking for a particular error or any error. Okay, so that's all you need to know about the catch block. Okay, sorry, I accidentally clicked that. And then the finally block is just used for cleaning up. Okay, so cleaning up includes everything from removing objects from memory to closing connections, even deleting certain types of variables. Any of these things could be considered cleanup. Okay, and all of that goes inside the finally block. Okay, so I can only see your initials, but DS, you were correct, it is the last one. You close the SQL connection, you close the connection to the database inside the finally block. Okay, because that's where you do all the cleanup, all the closing of connections, all of that kind of stuff. It's explicitly what the finally block was designed for. Okay, so without you, it's, in fact, I think it's probably better when you get to these try-catch switch statements, because there's so many different, try-catch finally statements, because there's so many different types of errors, and there's so many different types of high-risk code that you might want to put inside a try block. It's probably better if you don't think about the details. Okay, think about the overall structure. Any high-risk code can go in the try statements. Okay, anything that might cause an error. Okay? Any type of error can be caught by the catch statements, and any cleanup or any connection closing or cleaning of memory or deleting of things, that all happens in the finally block. Okay, so that's, rather think about that overall structure rather than the specifics of how try-catch statements work for particular objects. Okay. Are we okay with that, guys? Alright. You are developing a C# program. You write the following code. Here again, a bit difficult to read, but line 1, we're just creating a variable that's value is 0. Line 2, we're starting a while loop that runs while counts is less than 5. Okay, line 3 is just opening the block of the while loop with the curly brackets. Line 4 is saying if counts equals 3. Okay, so it checks if counts is equal to 3. And then line 5, break. Okay, line 6 adds 1 to counts, and 7 closes the while loop. And they're just asking you how many times will we enter this while loop. A bit of a tough one if we don't remember what the word break means. Let me copy the code into .NET Fiddle so that we can see it more clearly. So they say int counts. Ooh, good job, AP. our count is less than 5. Okay, so we have this structure, and then we have if count equals 3, and then on the next line they just go break, and then we add 1 to count. Okay. So pretty simple while loop structure, right? The only trick here is what is this if statement doing? Okay. And as AP's correctly pointed out, this stops the while loop early. Okay, so when I run this, ooh, I don't print out count. Silly of me. Let me actually make it do something. Console.writeLine count. Okay, so count is now being printed out. And we can see this prints out 0, 1, 2. Now don't let that trick you. Okay, hold on. Let me put the count before instead. Okay, I'm going to print out here because AP is correct. It is running 4 times. Okay, you see it prints out 4 numbers. Okay, let's go through what's happening here. Okay, in a bit more detail, just in case someone, because I can picture, I'm not 100% sure, but I can picture that some people might find this a bit complex. So we create this while loop, all right, and it runs while count is less than 5. Okay, so it will run on count equals 0, it will run on count equals 1, it will run on count equals 2, and it will run on count equals 3. Okay, so hopefully we can understand the basic while loop structure and how it'll just count up these numbers. Okay, now the trick is, what is this if statement doing? Okay, so this if statement is asking the question, does count equal 3? Okay, so this variable count that the while loop is counting up as normal, does it equal 3? Okay, so when it equals 0, it doesn't equal 3, obviously. When it equals 1, it doesn't equal 3. When it equals 2, it doesn't equal 3. When it equals 3, it does equal 3. Okay, when count is 3, this if statement is true, and so it runs this line. Okay. So now it's the question of, okay, when count equals 3, it will run this line. What does this line do? Okay. Hopefully we remember what a break statement does. It simply skips out, it just immediately stops and goes here. Okay. Goes to the end of the current block, okay, the current set of curly brackets, and just stops. Okay, so this will run on 0, it'll run on 1, it'll run on 2, and it will run on 3, so that's the 4th run. But when it runs on 3, it will run this if statement, okay, and break out of the while loop and stop, so it won't execute anymore. Okay, so the answer is 4. Okay, because notice how they word the question. They ask you, how many times will we enter the while loop? Okay, and the answer is 4. Okay, everyone comfortable with that explanation? Yeah, cool. Okay, if you are developing, I didn't mean to click, sorry, we haven't even read the question yet. You are developing a C# program. You write the following code: int I equals 6, just creating a variable. Okay. Int I equals 6, do if I equals 3, break, console.writeLine, print out I plus, while I is less than or equal to 5. How many times will the control enter the while loop? Okay, someone's already said 1, and that is the correct answer. I also gave it away a bit when I answered the question here. But let's also see, why this is. Sorry, I can't gauge how easy you are finding each of these. This question was quite easy, I think. So let's say, let me just write it out here. Okay, so we started by saying int I equals 6. Okay, do the while condition was while I was it less than or equal to 5 or less than 5? I'm not sure, it doesn't really matter. And then it said console.writeLine I plus, something like that. Okay, so what are they testing here? They're testing that, do you know that even though int I equals 6, and this loop runs while I is less than or equal to 5, do you know that this will still execute? That's all this is testing. Okay, and hopefully you do know by now that because it's a do while loop, it won't check the condition the first time, and so it will always run at least once. Okay, so even though the condition is already false before this loop has even started, okay, before this loop has even started, I is already 6, and the loop's condition is I is less than or equal to 5. So you can see if this was a while loop, it wouldn't have run anything. But because it's a do while loop, it sees do, it executes this line, see it prints out 6, and then it adds 1 to I. And then only it sees the condition, and it'll go, oh, okay, 7 is not less than or equal to 5, because I's value will be 7 by now. And then it'll stop. Okay. So all this is testing is, do you know that the do while loop will not check the first time it runs? Okay. Not too bad, hopefully. Okay, so this was, and actually because do while loops are so uncommon to see, when you do get asked about a do while loop, you can kind of assume that they're asking a weird question like this, where the condition is immediately false. Okay. Like when they ask you, oh, we need a loop that runs at least once, you can immediately kind of go, okay, do while loop. Okay. So yeah, that is correct. Okay. You are writing a C# program. You need to select an appropriate repetition structure for your requirements. You need to make sure that the test for the termination condition is performed at the bottom of the loop rather than at the top. Which repetition structure should you use? Okay, I think it's maybe a bit weird of them to give you these both in a row, but hopefully if you got the previous question, then this one should just be totally trivial to you. Yeah, exactly. Okay, they're wording it a little bit. Actually, we saw this exact question last week as well. They're wording it a bit weirdly by asking you, the condition is at the bottom, right? Like, in code, bottom is kind of a weird word to be using, but they literally mean at the bottom of this structure. Okay, so here is the condition, right? Here is the do while loop. You can see the condition is at the bottom of the do while loop. Okay, so it's testing the condition after it's run the first time. Okay, so the answer is do while. It tests the condition at the bottom of the while, at the bottom of the loop. Okay, so again you can shout at them for their wording, but it's the only way to make a multiple choice test even mildly difficult, right? Is by tricking you on wording like this. Okay, the next question, hopefully 100% of you got right. Okay, you are developing you are developing an algorithm for a retail website. You need to calculate discounts on certain items based. Okay, everyone's already answering. Let me just go through the example. Okay, so they say that the customer buys 50, so this variable quantity is 50. Okay, so we go through each of these 3 questions. In the first column we say, is 50 less than 10? No. Is 50 less than 50? oh wait, did I answer that correctly? Yeah, I did. Okay, sorry. Is 50 less than 50? No. Is 50 less than 100? Yes. Okay, so we got no for the first question, no for the second question, yes for the third question. So we go to the column that says no, no, yes. Okay, so this first one says yes, yes, yes. Second one says no, yes, yes. Third one says no, no, yes. This is the column we look at. We go to the bottom and we see, okay, 15%. And we answer the question. Fantastic. Okay, question 16. Okay, we've got 6 minutes left. This one is a bit tough. The reason I did say last week we would go through the scenarios first. The reason we didn't go through the scenarios first is because you'll notice this is the second scenario in your book. So at the end of that knowledge assessment we did last week, this is the second scenario. Maybe some of you, I'm interested, does anyone know the answer to this question? Is anyone willing to... Ooh, fantastic. Well done, guys. Okay, and what's fantastic is if you were super concentrating during our explanation of factorials, maybe you could kind of look at the flowchart and immediately go, oh, I don't even have to know what this is doing, right? You didn't actually have to go through the flowchart. Because going through this entire flowchart step by step with the number 5 would take you quite a while. It would take you, a good few minutes. But hopefully you could see instantly by looking at this loop structure, okay, we had a loop that was counting down and multiplying each number in that countdown by the value that fact previously was. Also the fact that the variable was called fact, maybe was a bit of a hint, factorial. Okay, and then you could just remember, okay, 5 factorial is 120. Okay, now when we do the scenario, we will cover all 3 of the scenarios next week, because this question will take quite long to cover in depth by going through step by step. What we're going to do next week is literally take this flowchart and code it up, okay, step by step. And then maybe this question will make more sense to you. But yeah, mates, this was kind of testing if you remember the definition of a factorial. Okay, and yeah, 120 is correct. Okay, 5 times 4 times 3 times 2 times 1. And you can kind of see n will count down by 1 each time, so it starts at 5, then becomes 4, becomes 3, becomes 2, becomes 1, and fact is just multiplied by n at each step. Okay, so we have fact initially equals 1, n initially equals 5, so it was 1 times 5, then it became 5 times 4, then it became 20 times 3, then it became 3 times 2, and it stopped at 1. Okay, you're allowed to stop at 1, because obviously multiplying by 1 won't change anything. And also technically they multiplied by 1 at the first step instead, right, because fact started at 1. Okay, but we'll go through in more detail when we get there. Okay, you are writing a C# program that needs to iterate a fixed number of times. You need to make sure that your code is easy to understand and maintain, even when the loop body contains complex code. Which of the following C# statements provide the best solution for this requirement? And they give you all 4 of the repetition structures we've covered. Okay, because of how this... Oh, okay, maybe I'm wrong. Okay, so this is it is quite an easy question apparently based off of the answers. The answer is 4. Okay, it is a bit of a trick though, right? Because if you find it particularly easy to read while loops, then maybe this would be a bit tricky for you, right? Because it's like, what do we mean easy to understand? Okay, so what they're asking there is they're really prioritizing this idea of a for loop being neater than other loops. Okay, because in the for loop, all the important parts of the loop are in this little set of brackets here, right? This contains all 3 of the important parts of our loop, and then as they say in the question, we have all this space here for our very complex code. Okay, so they're saying this is neater than a while loop. I agree, but maybe if you weren't sort of familiar with the language that they're using to describe this, it could be a bit tricky. Okay, but hopefully seeing it now, you can see why they would call this easier to read, easier to understand, all of those kinds of things they'd associate with this. Okay, and the answer is for loop. Alright, so that is the whole test. So what I can gauge is maybe people, were maybe struggling with this little trick, the ++ x versus the y++. Maybe the try catch finally block is still a bit tricky for some people. Yeah, that's what I'm gauging. But otherwise, it looks like you guys were pretty okay with the test. Don't worry about marks too much yet. It's still early days, and it's only the second time you're seeing something like this. Still got 5 more sections to go through, and we'll make sure that we go back and revise earlier knowledge each time. but it looks like you guys did okay. So that's what's important. Now let me see if I can hang up on my phone without cancelling the entire meeting. Great. Okay, that works. They put the buttons right next to each other. Ugh. Okay, so yeah, that calls it for today. I'm gonna actually wait to finish the recording, because last time when I finished the recording during the meeting it just froze. So cool. If there's any question in the test that is still particularly worrying you after we've gone through it, then please note it down and ask me at the beginning of next week's lecture. Next week's lecture we're going to go through those last 3 scenarios of chapter 1, and then that closes chapter 1. We're done with it, and then we must really hit the ground running on chapter 2, because we've lost maybe a lecture or 2 on that. So yeah, chapter 2 is not that difficult. It's very theory based though, very theory based, and it'll be it's difficult to show examples of object-oriented programming without programming an entire app, you know. So we're going to be using lots of slides, lots of sort of abstract examples, but yeah, hopefully that's okay with you guys. But yeah, it is more theory based, so lots of slides, lots of note taking. Don't hesitate to, you know, highlight and make notes in your book the whole time. Okay, and ask lots of questions about the things you're worried about. Okay, so I can stop sharing my screen now. Cool. So yeah, see you guys next week, and I'm posting the video on YouTube this time. YouTube takes a bit longer to process the video before you can share it, so it'll come out a bit later, but you will be able to watch it instantly now, and it won't be taking up space on my Google Drive. You know, for my whole life I've used maybe 400 megabytes of my Google Drive, even less, and in the last few weeks, just from all of these 2-hour videos, it's gone up to like 5 gigs. So yeah, I'm using YouTube from now on to share the videos, and I'll put all the previous videos into like a YouTube playlist so that you can easily skip through them. But yeah, see you guys next week. What channel? It's just my YouTube channel. I'll share the video on the WhatsApp group though. Yeah, you too. Enjoy the rest of you. Enjoy the weekend and next week and stuff. Cool.
Good weekend, sir. Thanks.
Yeah, you too. Okay, so this time when I leave the meeting, it will be closed. It's not like Microsoft Teams, okay? Everyone will be kicked. Cool. So, okay. Bye-bye, guys. Cheers.